right, working example number 2, powers with positive bases. So evaluate each power. So when you've got a 2 as your exponent, you can read that, in this case it would be 4 squared. So you can just say that it's squared. You don't have to say that it's to the second power or anything like that. You can just say that it's squared. So we're using a model of a square to show any power with an exponent of 2. Each side of this particular square is 4 units. 1, 2, 3, 4, 1, 2, 3, 4. So the area of this large square is, well, there's 16 little squares in here, so it's 16 small squares. In the the power of 4 squared, the base is the 4 and the exponent is 2. And we know that that means that it's 4 times 4 is equal to 16. So when you've got a power and 2 is your exponent, you can illustrate that using a diagram of a square, with your side length being your base and your area is the solution of the squared power. With 2 to the third power, we can illustrate that using a three-dimensional model, and this is read as 2 cubed. So when you're dealing with cube, you can use a model of a cube to show any power with an exponent of 3. So in this case we have a cube rather than a two-dimensional square. Each edge is going to be the base, so in this case it's 2 by 2 by 2, 2 units. And the volume now is the solution to the power 2 cubed. And in this case we've got 1, 2, 3, 4 squares on top and another 4 on the bottom, so our volume is 8. So in this case, 2 cubed, the base is 2, and the exponent is 3. And as we've already counted, the solution is 8. So you can do volume using the cubed category of powers. All right, let's move on to example C, 3 to the 6th power. So in this, the base is the number 3, and the exponent is 6. Now, sure, we can use your calculator and do 3 times 3 times 3 times 3 times 3 times 3, 6 times to get your answer. But that gets pretty tedious. As those exponents get to be large, punching in each number over and over and over again is ridiculously tedious. Now, we can use your calculator to shortcut this, and the button on your calculator probably looks very much like this one right here, where there's a y as your base and x as your exponent. And the way you're going to do this is, well, clear your calculator, and so for this example, 3 to the 6th, you start with the number 3, then punch in this y to the x button, and then type in your exponent, and then equals. And it will give you the solution to the power. So in this case, it's 729. Now, with this example, 3 to the 6th, you could think of it as 3 times 3 times 3 times 3 times 3 times 3. You can group them into pairs, which is fine. And if you do that, each pair, 3 times 3 is worth 9. So we've got 3 pairs, so we can do 3 9s. Well, this is still repeated multiplication. And if you've got 3 9s, then you could have a base of 9 and an exponent of 3. It has the same value. You can group them differently again. You can group them in groups of 3s. 3 times 3 times 3 is 27. So we've got 2 27s. So that's the same as 27 squared. So there's different ways you can approach this. If you, for instance, are lacking your calculator and you don't want to punch all these in, you can do some groupings and then manually calculate your multiplication on a few smaller numbers or bigger numbers. So there's different ways you can approach it. Next up is another show you know. In this case, we've got a chart to fill out with repeated multiplication and then evaluate it, find the solution to the power. Go ahead and get started.